Our I can statement for today is E1. I can create equivalent expressions by A, combining like terms. So this is the first part of a three-part series for creating equivalent expressions. Here's some key vocabulary you can fill in on your notes. So number 1, an expression is a mathematical phrase that can contain numbers, variables like x or y, and operations like add, subtract, multiply, and divide. A term is a single number or variable, or numbers and variables multiplied together, which are separated by a plus or minus sign. Pause the video if you need more time to fill this in on your notes. So go ahead and label on your notes these three sections. So this entire thing, 3x minus 1, is an expression because it has numbers, symbols, and operations. However, we have two terms. 3x is a term and minus 1 is a term, and they're separated by that minus or negative sign. Something that's important to remember: the term is always going to include the sign in front. So the minus sign becomes part of the two terms, so it's a -2. All right, so the instructions say sort into two groups of like terms in the expression. Okay, so what I'm going to do is anytime I see a variable, I am going to write it on a pink sticky. And anytime I see a constant term, I'm going to write it on a green sticky. So remember, a constant is just a number without a variable attached to it. Okay, so let's take a look at our first one. My first term is 3x, so I'm going to grab a pink sticky. And I'm going to use my whiteboard marker to write 3x on it. My next term I see is a -9, so I'm going to grab a green sticky. And I'm going to write -9 on it. Remember, the sign goes with the term in front. Now you may be thinking, well, isn't that 3x subtract 9? And yes it is, but remember that subtract signs and negative signs are equivalent because of keep, change, change. We could rewrite that as 3x plus -9. All right, our next one is -6x, so we're going to grab a pink sticky. And I'm going to write -6x on that. And then my last number is 10. So I'm going to grab a green sticky. And I'm going to write 10 on it. Now, I was kind of sneaky and I kind of already did this as I went, but if you haven't already, go ahead and organize them so that all your pinks are together and all of your greens are together. So what we've done is we've sorted this into two groups of like terms in the expression. If I wanted to, I could list them off to the side. So my one group is 3x and -6x. My other group is -9 and 10. So those are my two groups of like terms. So what I just wrote here is what you would write for your answer for this type of problem. All right, now we're going to try it this time, but instead of using stickies, I want to show you how you can use your pen and pencil. So this time, anytime I see a term with an R in it, I'm going to put a box around it. So I have plus 0.5R. Notice I included the sign in front. And then I have -7R. So those are my two R terms, and I can go ahead and just list those. So 0.5R and -7R. Then I'm going to put a circle around any term that has a constant in it. So -4 plus 8. So those are my two groups of like terms. Okay, now I'll show you this is exactly the same as if we had used our stickies. If I had written them on the stickies, I would have had 0.5r and negative 7r on the pink and negative 4 and 8 on the green. So those are my two groups of like terms. So now what we're going to do is we're going to simplify this nice big long expression by creating an equivalent expression with the least number of terms possible. So I'm going to sort these into groups of like terms, and then I'm going to combine them. So here's what it looks like for my first step. I'm going to grab a green sticky to put that 8 term on. And remember, if you're doing this by hand, you could also just circle that 8. So there's my 8. And then I'm going to write 8 on my green sticky. Okay, the next term that I see is a negative x, so I'm going to put a box around it, or I can grab a pink sticky, and I'm going to write negative x on it. My next one is also another x term, plus 7x, so I'm going to put a box around it, and I'm going to grab another pink sticky. And I'm going to write on it 7x. Then lastly, I have my plus 1 over here, so I'm going to grab another green sticky, and I'm going to write 1 on that. So I've sorted them into two different groups of like terms. Now I'm going to add up like terms, okay? So I'm going to add together negative x and 7x. Now, if there's no number in front, imagine there's a 1. So I've got negative 1 plus 7 is going to give me 6x. Then I'm going to add straight down. 8 plus 1 gives me 9. So my final answer for this is 6x plus 9, because I've simplified it by writing it in the least number of terms. Now you might be thinking, well, can I add together 6x plus 9? No, you can never add unlike terms. So I want to make that very clear. On your test, if you were to write, oh, this equals 15 or 15x, you would be wrong. Okay? So 6x plus 9 is our final answer. Okay, I want you to try to simplify this one on your own. Now don't be thrown off. There are 3 y terms. You're going to add those together. And then you just have the one constant term that will be part of your final answer. Go ahead and pause the video and try this one on your own. All right, so the first thing I did is I'm going to put boxes around all of my y's. And I'm including the sign in front. And then I'm going to list them out. Negative 1.2, 7, and 10. Now remember, the numbers in front are the number of y's that we have. So we're going to total them up. Now you can type into your calculator negative 1.2 plus 7 plus 10, and that's going to give you the final answer for the number of y's we have. Okay? And make sure that you note that both 1.2 and 10 are both negative. When I typed those up into my calculator, I got negative 4.2y. And that makes sense, because if I have negative 10 and 7, those added together would be negative 3. And then I'm going to add in 1.2 more negatives. The next thing I'm going to do is I'm going to circle my 1, which is negative. And if there were any other constants, I'd list those and add them up. But since there's not, I can just bring that down as part of my final answer. So my final answer is negative 4.2y plus negative 1. Notice that I always want to use a plus here. The sign for the second number might be negative, it might be minus, and that's fine, but I just want you to remember so you don't get confused. If you were to write this as negative 4.2y minus 1, I would also accept that, but I don't want you to write negative 4.2y subtract minus 1, because that's a different number sentence. Okay? Also, while we're on this note, it is mathematically equivalent to write -1 plus -4.2y. You can switch the order, but mathematically speaking, it's more correct to have the y in front. It's kind of like if you write a sentence without capitalizing the first letter, I can still read the word you're writing, but it's not grammatically correct. So we always want to put our y's first. Okay, now before you try this one on your own, I want to point out that these parentheses are grouping symbols that are grouping the negative with the 3x. They are not absolute value symbols, okay? So it is perfectly fine to think of this equation as 4 plus -3x minus 2 plus x, okay? For order of operations, there's nothing we can actually do inside the parentheses yet, okay? So maybe start from the red expression that I've got here and combine like terms. And start back up the video when you're ready to check your answer. Okay, now I have plus -3x and negative and positive, and we want to include that negative because we could change it to subtracting a positive, but either way we would have that negative sign. So -3x plus x, so that's, remember, plus 1x. So -3 plus 1 is going to give us -2x's. 4 plus -2 is the same as 4 subtract 2, or +2, and then I'm going to put a plus sign in the middle. So -2x plus 2 is our final answer. Okay, try this one and start the video up when you're ready to check your answer. All right, so I need to combine my -y, and remember you can think of that as -1y plus 4.25y. So I'm going to have 3.25y, and then I have -2.5 plus 1, so that's going to be -1.5. All right, now this one has fractions in it, but we don't need to be alarmed. We're going to follow the same basic steps. So I'm going to box my m's. So I have 1m, and if it's helpful for you, you can write the 1 in front. You don't have to, but I find for a lot of students it helps them to make sense of this. Then I'm going to put a box around the -2m. So I'm going to total up the number of m's that I have. 1 minus 2 is going to be -1m. Okay, remember I could write it like this, or I could write it as just -m. Either way works. Then I'm going to add together my constants. So I have -1/9, and I'm going to add 5/9. Okay, so imagine that I have a pan of brownies that I cut into 9 equal pieces. Okay, so I have 5/9 left over, and then I'm going to take away one more. I'm going to end up with 4/9. Okay? Now, you could have just typed that into the calculator as well. -1/9 plus 5/9. But either way, my final answer for this is going to be -1m plus 4/9, or you could write that as -m plus 4/9. This is technically the most correct way of writing it, but I would accept either answer. Okay, now this one has fractional coefficients, meaning the numbers in front of y are fractions, but it doesn't change the steps. So the first thing you're going to do is put a box around all the terms with y's, and make sure to include those signs. And then let's list them. So I have 1/3 y minus 2/3 y plus 2/3 y. And I could type into my calculator 1/3 minus 2/3 plus 2/3. Okay? So that subtotal is going to end up being 1/3 y. And here's why. We have positive 2/3 and negative 2/3 that are going to add up to make 0. Okay, so it's like they disappear and we're just left with that 1/3 y. Now I need to add up my constants. In this case, I just have the 6. So I'm just going to bring that down to be included in my final total. So I have 1/3 y plus 6 as my final answer. Okay, so even if adding and subtracting fractions is still kind of tricky for you, you can use the calculator using the same steps we've done before. All right, that's it for today's video. Remember that you can watch it as many times as you need to. You can pause where you need to make sure that you're understanding these concepts. Thanks for watching.